Okay, this is going to be our first revision video. It's going to be on probability, as that was requested first. So we're just going to go through some key points. So remember, mutually exclusive events cannot happen at the same time. So you can't be late and early to school. Okay, so sometimes you have to give reasoning or what you assume. So make sure you remember this key word, mutually exclusive. The other one is independent events. If one event does not affect the other event. So it could be you being late has no effect on your friend being late. Okay, they're independent. You go to school differently. Okay, and then if they are, we just multiply them. Okay, like on a tree diagram. This B is not affected by A. Okay, and then lastly, conditional probability, when one outcome affects another outcome. Okay, so the second probability will be different based on the first probability, and that's when the denominator changes on the tree diagram. Okay, so we're going to go through some questions. You need pen and paper. I have no print paper, but I'll get some, so I had to write them out. So let me just make sure it. Okay, pause it and try that one. Okay, so hopefully you paused it. So if we look at this one, we're starting off with the basic sort of ones. So in a lucky dip, you either win a toy, pen or pencil. Find the probability of a toy. Well, if you can only get these three, we know they add up to 1. So add them up. Add these up. Equals to 1. Okay, so that's my probability. Remember, a fraction is fine. You don't have to change it to a decimal. So part B, in a raffle, a free ticket is given with every ticket sold. Stephen thinks this could double his chances. Is he correct? So you should have wrote, no, everyone gets a free ticket. If everyone gets the free ticket, he's at no advantage. He's not double everyone else, so everyone else got the same as him. Okay, so you should have said no, everyone gets a free ticket. Okay, the second one, I'm going to put it here. You should pause it and try it first. Okay, so let's look at this one. The probability that Sarah is late is 0.3. The probability that Andy is late is 0.5. Sarah said that the probability they're both late is, you multiply them, 0.15. What has she assumed? So if you remember the cards from the start, she's assumed that they don't affect each other. So if they don't affect each other, she's assumed they are independent events. Okay? She's assumed they're independent events. When we multiply them as they are, they're independent. Andy is not affected by Sarah, and Sarah is not affected by Andy. Okay, that's what she's assumed. So let's move on. Right, next one, Venn diagrams. So pause it here and try. Okay, so that thing means these numbers need to all be included. Okay, that's what it's out of. Now we've got square numbers and even numbers. So the square numbers, we know, are 1, 4, and 9. Okay, there's no more square numbers. The even numbers, 2, 4, 6, 8, 10, and 12. Okay, so which ones are not included in any of those lists? Well, we've got 3, put them outside, 5, 7, 11, yeah, that's it. So which ones are square numbers and even numbers? So it's only 4, the number 4, okay? And then square numbers, you've got 1 and 9 left. And here, you've got 2, 6, 8, 10, and 12. Okay, so that's completed the Venn diagram. Now write the probability of S and E. So you want S and E together. So you want a square number and it has to be even. So we've only got one number, which is 4. So it's 1 out of, and there's 12 numbers. Okay, don't write 4. Remember, it's probability. How many is one number? So it's 1. Okay, and this one, because remember this and is just the middle part. Okay, now this one, the or, you need that S or E. You want the whole thing, not the outside though. So 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 out of 12. Don't worry about simplifying unless it tells you to. You're not going to get no more marks. Now this dash, remember, it means not S. Okay, so the probability of not S. So if you look here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are not S. Okay, remember 4 is in the S circle, so we don't want the 4. Okay, so check your answers. Hopefully you've done them. So let's move on. The next one, the Venn diagram is a bit more tricky, but not that much. So you've got, again, the total, remember? So pause it here and try. Okay, so that means 120 coins in the collection. T is coins from the 20th century. B is British coins. So you know, they're not mutually exclusive. They can happen at the same time. It can be from the 20th century and it can be a British coin. Okay? So coin is chosen at random. It is British. Work out the probability that it's from the 20th century. So I need to work out the probability of it being British, and it's also from the 20th century. Okay, so it's this bit. So that's what I'm trying to work out, what X is. Okay, because that equals to X. So I know there's 120 coins. And I know 32 of them are not included in this. So let's take that away. 120, take away 32. So it's 88. So I know all these added, okay, is going to give me 88. Then I can find the value of X, and that's going to be my final answer. Okay, so 88 is the whole diagram, because that's what's left over. So I'm going to add them together. Plus X minus 2 is going to give me 88. Okay, now remember, expand the bracket. Let's simplify. And we need it, hopefully you realise it's a quadratic. So plus 2 to both sides. No, you minus 88 to both sides. Okay, now we need to solve the quadratic. So two numbers, they multiply to give me minus 90. They add to give you minus 13. So I'm solving it by factorising it. If you don't know how to solve by factorising, then I don't know where you've been. Okay, so two numbers give you 18. Hopefully you thought about it when you tried it by yourself. So minus 18 and 5. Okay, now if I put it in a bracket, so X equals 18, X equals minus 5. Now X is the number of coins. It can't be minus 5. So that is my only solution. Okay, so X equals 18. Look at the next one and pause it and try. Okay, so represent on a Venn diagram. So it has climbing and has sailing. 50 children attend the activity, so you know the whole thing needs to add up to 50. Okay. 2 children do neither class, so 2 is going to be here. 10 children do both classes, so 10 is going to be here. 35 children do climbing, so 25 is going to go there, because that means the whole climbing circle adds up to 35, not just this number. Okay, now we know the whole thing adds up to 50. So if we add these up, take away from 50, we're going to get 13. Okay, now find the probability the child did exactly 1 class. Well, if they did exactly 1 class, it's going to be these people done only climbing, these people done only sailing. So add these together, 25 and 13 over the total, which is 50. So 38 over 50. So that's my answer. Okay, what's the probability they did sailing, given that they did not do climbing? Okay, so they did sailing. So let's look at sailing. So it's out of, given that they did not do climbing. So we cannot include this climbing circle. Okay, so what's left over? 15. So you know your denominator is going to be 15. That's conditional probability. The condition is they did not do climbing. Okay, so this 35 is out of it. And they did sailing. The probability they did sailing. Sailing is 13. So it's going to be 13 out of 15. Okay. So let's move on. So I'm going to show you this one and pause it. Okay, so when Kayla shoots an arrow, the probability that she hits the target is 0.3. Each attempt is independent of any previous shot. So what's the probability she misses? Is 0.7. Okay, so the probability that she hits the target for the first time on her 3rd attempt. So that means she has to miss, and because they're independent, I can times miss times times she hits it. Okay, so the probability she misses, 0.7, times the probability she misses times the probability she hits it. Okay, and that'll give you 0.147. Okay, and the next part, check whether or not there is more than a 50% chance of Kayla hitting the target once, only on her first 3 attempts. So that means she needs to do, you could draw a tree diagram, that's fine. Or you could think, okay, because they're independent, tree diagrams, for working out, it's better when it's conditional. When it's independent, you can just think, okay, that means she has to exactly once, okay, on her first 3 attempts. It doesn't matter when she does it. So she could miss, hit, or she could miss, hit, miss, or she could hit, miss. Okay, and we know the probabilities. So miss times hit. And remember, you've got to show you working out. Miss times hit times miss, hit times miss times miss. Okay, and then what do we do to all our options? We add them. So when I add them all together, you should have got this. How do I convert that into a percentage? Times by 100, so 44.1%. Okay, so we'll check whether or not there is more than. So no, it's less than 50%, isn't it? Okay, now the next one I want to show you, and pause it. Okay, so fairground game consists of removing 2 balls at random from a box containing 15 blue balls and 5 red balls. A player wins the game if 2 red balls are removed. John calculates the probability of winning the game is a quarter squared equals 1/6. What's he assumed? Again, he's done the probability quarter times quarter. So he's just done that. And that's like this, what we saw at the beginning. Okay, so he's assumed, okay, the independent events. If the independent events, that means the ball is replaced. Okay, they put the ball back. Okay, so assume they put the ball back, so they're independent events. If he didn't put the ball back, the next probability will be conditional because it will depend on what John got, what colour he got in the first probability. Okay, the next part, if John's assumption were not true, what effect would this have on the probability of winning the game? Well, if it wasn't true, the probability at the start would be a quarter. Okay, it would be a quarter because 5 over 15 simplifies to a quarter. But then, the next time he does it, he's not gonna have, well, he's gonna have one less, isn't he? It's not 15, it's 19, sorry. It's 20, sorry. Okay, that simplifies to that. And the next time, he's gonna have 19, because he's already picked one, it's not replaced. Okay, and then he's gonna have 4 reds left. So he needs 2 reds, remember? And that, if you did it, simplified it, it would just be this. So it's, if you look at that probability, look at that probability, it's reduced because that's smaller fraction than that one. Okay, hope that makes sense. Please comment if you're not sure or you want me to do an answer a question similar because you want to practice it more. Okay, last one. A little bit harder tree. So pause it. Okay, so this one, the last one, it says there are 10 pens in a box. There are X red pens. All the other pens are blue. So Jack takes at random 2 pens from the box. Find expression in terms of X for the probability that Jack takes 1 pen of each colour. So I can use a tree, but I don't need to do the whole tree. Red pens and blue pens. So I need to do different colours. So I'm only going to do red and blue, then red. I'm not going to do this one because it's not going to help me with my calculation. So what is the probability of getting a red? Well, there's 10 in the box, so I know my denominator is going to be 10. There are X red pens. Okay, so I know there's X red pens. Okay, all the other pens are blue. Okay, so if he picks a red one and he takes at random 2 pens, so he doesn't put it back, so my denominator is going to be 9. If he takes a blue pen, remember the rest are blue, it's going to be the total take away X. Okay, and that's because if red is X out of 10, blue is going to be the total take away X. So you take away X, all the rest you've got left are blue. Okay, that makes sense? So here, the blue is 10, take away the red, and that gives you what blue is. So here, blue, again, we know 10 take away X over 10. Okay, and then red, if you take a blue, the red's not affected. Okay, but there is one less. Okay. So now we need to do probability of red and blue. Okay, we can times them, but remember B is dependent on red. Okay, so times, okay, and then that gives us okay. If you want to expand it more, 10x minus x squared over 90. Now I need to do the probability of blue times red because it's got 2 options. So that will be that. Remember, show you working out. I know some of you realise something. So that will be x bracket. So it will be the same. And it says, give your answer in its simplest form. So I need to simplify that to make sure I get my full marks. Okay, or I simplify these two. So I want to add them together first because I want that and that. So if I add these together, remember when you're adding, the denominator stays the same. And the numerator got 20x, because they're like terms, minus 2x squared. Okay, what I need to divide all these numbers by a number. Only 2 goes into them. So it'll be 10x minus x squared over 45. And that's my final answer. Okay. So if there's any questions you were like, what? Or you want me to go over, I will have a stand for my camera, so it's not so wobbly next time, hopefully. Again, comment the topics. I think about 6 topics people have commented. If you're not commenting the topics you want to do, they might not come up. If there's an exam question you're struggling with, take a photo or just write the start of it. I'm sure I'll find it. I'll show my homework. Okay.